And welcome everybody to the Daily Space Weather. We are looking at the sun here in 304 angstroms. We've got another Earth-directed coronal mass ejection on the way, one anticipated to strike today, despite NOAA and NASA apparently not understanding this. Some sunspot groups moving into a setting region, also a coronal hole. We'll talk all about it. Here's a different wavelength from the Solar Dynamics Observatory, the SDO. It's 193 angstroms, ionized iron. And thanks for tuning in, Twitch, YouTube, and BitChute. By the way, I'm your host, Dan, a.k.a. smAsho, president and CEO of the Smash News Network, least busted name in news. Next thing we're doing here is we're looking at the view from Stereo A. So Stereo A is a super important spacecraft. If you're wondering where it's located, here's where it's located at Lagrangian point 5. So if you're looking at the sun from the perspective of Stereo A, Earth would be off to the right. And you can see once again here we saw an additional coronal mass ejection yesterday. Basically, as we were making yesterday's show, we saw this coronal mass ejection propagate. So there you have the coronal mass ejection itself. And what's interesting about this one is that it's not showing up on the LASCO C2 nor the LASCO C3. So this is the moment that it ejected. And since we're not really seeing anything on the coronagraph here, it's an indication that it is all obscured behind the disk. So this obscurement disk here, here's the LASCO C3. It's a zoomed out version of the same thing. Now, the LASCO spacecraft are located at Lagrangian point 1 here, part of the Discover suite of instruments. And you can see a bit of a halo emerging here, an indication once again that there is another coronal mass ejection. We can expect this to arrive in about 2.5 days. So we're also expecting one to arrive today, about midway through the day universal time. In a few hours, we're expecting to see a spike in the solar wind speed from a fairly diffuse coronal mass ejection, and this one's pretty diffuse as well, folks. I don't want to be alarmist about it. This is likely to strike the geospace. It's likely to cause a mild geomagnetic storm, KP5 or 6. So let me just bring up Stereo A again. Now we're back at Lagrangian point 5. And I'll let this play through here. You can see also a coronal mass ejection on the far side of the sun over here by my pointer. And here's the one that propagated as we did yesterday's daily space weather video. Again, we're expecting the arrival of that in about 2.5 days, 2 or 3 days, folks. And a geomagnetic storm of KP5 or KP6 from that. Not sure who's asleep at the wheel at NOAA and NASA right now. But that's part of the reason why we have a channel, because we are able to not only forecast these things ahead of time, but hey, what can I say? Here we are. So there's the information. Take it or leave it. Cheers. And we'll have to say goodbye to Twitch. We'll see you later, Twitch, for the cosmology and meteorology segments. Back to the daily space weather. Here are some more views of the closest star. Here's 171 angstroms in full disk. And that coronal mass ejection came from someplace around this area right here, I believe. Although, is it really important where it came from? By the way, no major solar flares associated with this coronal mass ejection. Once again, you have to watch the instruments. Otherwise, you will not realize that these occurrences are occurring. Here's a close-up of the southern hemisphere. We've got 3 sunspot groups that are setting here toward the right of the imagery there, and those have all degraded over the past 24 hours. Solar activity has lessened overall despite that coronal mass ejection. Here's a diagram of the solar system. We're going to advance this 1 week. There's where we expect things to be in a week. Here's a star chart. Oh, first, I would invite everybody to follow us on Instagram. Yes, here's our Instagram page. And we just took an image of the moon this morning, the moon through some trees. Instagram.com/smAshomash for greats like this. Here's a star chart. And we've got the moon setting here in eastern Pennsylvania. And we've also got Saturn and Jupiter visible there close to the ecliptic, which is this yellow line I like to use in -the-sky.org. My star chart is facing the south, as am I, and my sofa. The 10.7 centimeter radio flux has actually dropped back down to 79. And here's the radio flux, the most proportional aspect of solar data to sunspot number. This black line right here is the 1-year graph of the 10.7 centimeter, 2800 megahertz radio flux. The red line underneath is the sunspot number, and you can see this precipitously rising here. And we're expecting a sudden uptick in the radio flux as well, and an uptick in solar activity. So you can see here, NOAA's not forecasting anything for today. I'm expecting a geomagnetic storm sometime in this range right here on April 28th, and another one on sometime early in the day on April 30th. Not April 30th. How do calendars work? May 1st. Yes, May 1st. As there is no 31st day in the month of April. So May 1st, we're expecting another geomagnetic storm, geomagnetic unrest condition, KP 5 or 6, forecasted for today and for May 1st. Largest earthquake of the past 24 occurred near the Bhutan-India border. And it was initially reported at a 6.4 magnitude. It did lots of damage. It was later downgraded to a 6.0 magnitude by the U.S. Geological Survey. That one came in at 2:21 Universal Time today. Here's a news story about it from Daily Mail. And we've got some reports of destruction, some significant destruction here, some cracked walls as well as some collapsed structures, obviously. No reports of casualties yet at the time of this story. Continuing on to the list. Here's the past 24 hours of earthquakes. We saw a couple mid-5 magnitude quakes, such as these two at Papua New Guinea. A deep quake at Chile at a 4.2 magnitude at 103 kilometers depth. Some quakes in Texas as well. Less than a 4.0 magnitude, a 5.9 at the Kermadec Islands region, north of New Zealand there in the Kermadec Trench. Also a deep quake at Haveluloto, Tonga, at over 500 kilometers depth and a 4.5 magnitude. We saw a 4.8 in southern Alaska. Shout out to Brett. Did you feel that quake? Also a deep quake at the Bonin Island regions near Japan. Some aftershocks from that quake near the India-Bhutan border as well. And another deep quake at Chile at 101 kilometers and a 4.7 magnitude. Coronal is still erupting. Check it out. It's still filling up its crater valley. Yowzers! And I'm noticing that the rock here is now brown. So it was black earlier. Now it's actually brown. Has the chemical composition of the lava changed at Fagradalsfjall, Iceland? Will it entirely fill up the crater valley and start spilling down to the valleys below it? Leave us a comment. Let us know what you think. Next, the daily volcano rundown. Sakurajima is exploding, at least erupting. 7,000-foot ash plume above it. Suwanosejima in the Ryukyu Islands. 5,000-foot plume of ash there. Cinnabung exploding as well. Flight level 120. It's a 12,000-foot ash plume. Semeru on the East Javan Island, on the Indonesian Isle of East Java exploding. 14,000-foot ash plume there. That's a pretty significant uptick there at Semeru, if I remember correctly. Dacono, continuous emissions there, producing a 7,000-foot ash plume. Samisa-Pochnoi issued the following report: none. Popocatépetl in central Mexico, 19,000-foot ash plume there. Fuego exploding in Guatemala, 16,000-foot ash plume there. Sangay in Ecuador exploding, 20,000-foot ash plume there. Revenador also in Ecuador exploding, 15,000-foot ash plume there. And Sabancaya in Peru exploding. Sporadic puff emissions were enough to produce a 21,000-foot plume of ash. A great reminder to not pole vault the caldera. This public service message brought to you at massive personal risk and expense by Smash staff and I here at smAsho.com. And check out smAsho.com. Welcome to the Neo-Renaissance. Click our links. Support our channel, perhaps with some merch. One of the links you can click there is the smAsho merch, which will link you to our Redbubble page. Thanks for citing the issues with the link, Evan Clayson. Cheers. One of the items you'll find there is the Do Not Pole Vault the Caldera design items, our public service message. And why do we have such a public service message? Because here at the Smash News Network, we are all too aware that people are stupid. So we have to tell people not to pole vault the caldera. Now, I just ordered 3 pairs of these Do Not Pole Vault the Caldera socks. And as many of you are already aware, we cyclists express our fashion through socks, especially those of us who wear team kits all the time. So check out some Do Not Pole Vault the Caldera socks if you haven't done so. And let's get back to data from space. The GOES 16 is measuring X-rays in its sun-facing suite of instruments. By the way, it also has an Earth-facing suite of instruments. No major solar flares over the past 24 hours, just a bunch of B-class spikes. Some B-class solar flares as we approach solar maximum in a couple of years. And we've leveraged our channel accordingly on purpose. No spikes in the proton flux, and we're not really expecting any here. Even with the coronal mass ejections about to strike, they're not going to strike hard enough to cause spikes in this, I don't think, but we'll keep you posted. On the GOES magnetometer over the past 3 days, we've seen, at least over the past day and a half, we've seen high highs and high lows. So a tight range here, but it's not particularly high. It's just kind of at a higher average. It looks a little bit like a cryptocurrency chart, doesn't it? Leave us a comment if you own stellar lumens. Yes, stellar lumens, XLM. Did you buy some when we were telling you to buy some at 39 cents per stellar lumen? Next, looking at the heliospheric current sheet and its polarity. You can see Earth is in a North Pole current sheet shown in green. We're not expecting that to change anytime soon. Keep in mind the magnetic environment can suddenly change. Here's another view of the same data from the line of sight. It's essentially showing you a 3-dimensional image here of the heliospheric current sheet. And we're expecting a few days before the South Pole current sheet returns to the Earth, facing to the Earth's potential field surface source line. And here's the line of sight coronal hole plot. It's underperforming in that it should be showing us a more significant coronal hole in this area. I have no idea why it's not, but it's not. We've already showed you the 193 angstroms view from the SDO, and we're expecting a coronal hole wind stream from that in about 4 days. Next, looking at filaments, and we still do have some filaments here in the Earth-facing zone. For some reason, this map not animated. And again, the sunspot groups 2018, 2020, and 2021 have all degraded over the past 24. We'll show you close-ups of those later in the video. KP index currently at 1, and for you new viewers, the KP index is a measurement of global geomagnetism. Here at the Smash News Network, we're interested in global geomagnetism. We'll talk about it in a minute. First, the real-time solar wind. So we see very low levels of solar activity here. Current solar wind density all the way down to 1.78 protons per cubic centimeter, so a very diffuse solar wind right now. Solar wind speed just over 400 kilometers per second. And here's this low-density solar wind coming in here. We're looking at a geospace magnetosphere movie. It's 4 hours of data of the density of the geospace around planet Earth. And you can see all that light-colored area there. That is all low-density stuff. And it's what you're talking about protons per cubic centimeter here in terms of density. We'll also show you the pressure, which we're expecting to be quite low, and indeed it is. Similar pressure in the magnetotail region here as to the bow shock region, at least at the beginning of the 4 hours of data. And these geospace magnetosphere movies are courtesy University of Michigan. They are models based on the space weather modeling framework, and we'll let this play through as it has refreshed to annoy and astound. Next, we'll show you geospace delta B. Changes to the Earth's B field at the ground level, otherwise known as ground magnetic perturbations. And here they are. We're not expecting many until the coronal mass ejection that is about to strike the geospace arrives, likely today, in just a few hours, folks. How it is that NOAA and NASA haven't forecasted this, I have no idea. I just do my own work, and I don't really worry about the failures of others. Anyway, there's 4 hours of data. Changes to the Earth's B field, geospace delta B. And since we are now moving into our cosmology segment, let's welcome back Twitch viewers. Welcome back, Twitch viewers. Here comes our cosmology segment, but first, we'd like to thank our Twitch followers, our BitChute followers, our new subscribers over on YouTube. Thanks very much for subscribing over on YouTube. If you haven't done so, please press subscribe. And please share our content on your social media as the algorithms hate us. Today's cosmology segment should be interesting. It's got various stories here, and let's go. How about X-ray binary Maxi J1820 plus 070? It's a system consisting of a white dwarf having material siphoned off of it by a thing like a neutron star or some sort of a massive radio source. And this is a phys.org article in their astronomy and space section. And what they're noticing is a proportional relationship between the X-ray output and the rest of the electromagnetic frequency band. So the electromagnetic spectrum, folks, these objects have a proportional relationship between their X-ray output and things like their radio output or their infrared spectral output. And what we're talking about here is several outbursts and rebrightenings, which showcases an evolution trend similar to the outer black hole low-mass X-ray binaries, which is most likely a result of temperature change in the outer disk during the outbursts. So the point is, folks, there is a relationship between the toroidal fields and the poloidal fields of these objects. And they're looking at phase transitions here. The pseudo-equivalent width of emission lines exhibit anti-correlations with the X-ray flux, which could be due to the increased suppression by the optical continuum at around the X-ray peak. The full width at half maximums of hydrogen and helium lines appear to stabilize at the 19.4 and 21.8 angstrom wavelength. So according to this paper, it corresponds to the line-forming region at a radius of 1.7 and 1.3 solar radii within the disk. So that's sort of a sweet spot within the toroid. There is a disk of ionized gas and dust between these objects, and there's a Lagrangian point 1 associated with these outbursts and so forth. Perhaps read this article. And there's a link to the paper as well here. There is not a link to the paper. Anyway, this one is about Maxi J1820 plus 070. We won't worry about looking at that one. And let's talk about neutron star skins. Here's an article on SciTech Daily. This isn't really a test of neutron star skins. This is a test of the properties of the nucleus of lead atoms in the laboratory. So the neutrons are believed to reside in a shell around a spherical clump of protons in the nucleus of a lead atom. And this has some sort of an effect on the belief of what neutron stars are made of. We just continue to call neutron stars massive radio sources, as their radio and X-ray and other spectral outputs are something that we can actually measure. So perhaps read this one. Does it really tell us anything about a neutron star? I'm not so sure about that, but it certainly does tell us something about lead nuclei. Now, this is the Crab pulsar, and I just wanted to bring up this image to cite a quick little thing here. One, this is the poloidal field of the pulsar. So you see that jet coming out there? That's coming out of the pole, and the poloidal field is probably shaped like a cone like this, not to be confused with the toroidal field, which is this donut-shaped region. And again, there is a proportional relationship between the spectral output from material in this field versus material in this field. And the Crab pulsar is a great place to illustrate this. Continuing on, and by the way, folks, these objects do not behave just as vacuums, they also behave as fountains. It's a combination of vacuuming things up and fountaining things out. And black holes, the objects, the massive radio sources referred to as black holes, do the same thing. There's a proportional relationship between the spectral output from the torus and the spectral output from the poloidal fields. And what you're looking at here, by the way, is this is X-ray, and I think this is infrared spectrum here. But this is certainly X-ray. That's certainly from the Chandra X-ray telescope there. Next, talking about muons, and let me preface this section with a quote from the article. A muon is about 200 times as massive as its cousin, the electron. They occur naturally when cosmic rays strike Earth's atmosphere. Particle accelerators at Fermilab can produce them in large numbers. Like electrons, muons act as if they have a tiny internal magnet. In a strong magnetic field, the direction of the muon's magnet precesses or wobbles, much like the axis of a spinning top. All spinning objects in the universe that we know of precess, folks. The strength of the internal magnet determines the rate that the muon precesses in an external magnetic field that is described by a number known as the G factor. This number can be calculated with ultra-high precision. And the calculation of this G factor is flying in the face of the standard model of physics. So we've covered this actually, I think, 2 other times before on the Daily Space Weather videos in our cosmology segment. And this is part of where the rubber hits the road between laboratory physics and what we see happening in space. This is very important, as are a lot of different features of physics. So perhaps read this article, or maybe just pause the video since we're scrolling the article here. And the point is, folks, we have not yet arrived at a unified theory of physics, which is part of our mission at smAsho.com. If you haven't read our mission, head to smAsho.com/forum/mission, and you can read all about it. The number 1 item on the list is assist, study, and report on the ongoing unified theory of physics. The ongoing formation of a unified theory of physics, folks. It's kind of important. Let's move on to today's astronomy photo of the day. It's Polaris. And if you want to know how to find Polaris in the sky, let me just show you the Big Dipper. So here's the Big Dipper. I'm just going to draw it like this. And these 2 stars right here, at the end of the cup of the Big Dipper, they point toward Polaris. So let me just draw that again. So there's the Big Dipper. These 2 stars right here form a line, and that points directly at Polaris, Earth's celestial pole. And of course, there are other celestial pole stars during Earth's precessional axial tilt wobble cycle, such as Vega and Deneb and some other stars. But in any case, today's astronomy photo is Polaris and the surrounding dust. If you want to check out the daily astronomy photos, it's apod.nasa.gov. And by the way, Polaris is a Cepheid variable, and Cepheid variables are part of the reason why I don't have an astronomy degree. And without going further into that, let's pick a random number between 1 and 1031. Today's random number is 802, which coincides with some object here at the Neil Gorell Swift Observatory. What might 802 be? Well, I'm wondering. Are you? We won't keep you in suspense anymore. 802 is SAX J1819.3-2525, a low-mass X-ray binary / massive radio source believed to be a black hole. And check it out. We've got some cyclicity here. We've got some voids in the X-ray outputs from SAX J1819.3-2525, a catchy name. Let's check it out on Simbad. Let's see what we can see. And it looks like it's in a very busy part of space. We'll take a look at this in some other wavelengths. So this is the DSS2, which is the optical band. Let's take a look at it in ultraviolet on the Galix. Does it show up on the Galix? No, it doesn't. How about on the Chandra? And there it is in X-ray. You can see it's a bit of an oblong X-ray source here. Not perfectly symmetrical. How about the XMM Newton? How about the Swift Bat X-ray flux? Nope. How about on Pan-STARRS? And actually a great view there, a pretty high-resolution view of it on Pan-STARRS. That's today's random object. Some object which I will never memorize the name of. And to quote Einstein, never memorize something you can look up. It's SAX J1819.3-2525. That's today's cosmology segment. And we'll have to say goodbye to Twitch once again. Bye, Twitch. We'll bring you back once again for the meteorology segment. Moving on to talk about electron flux. Here's the one-year chart of the electron flux, the greater than 2 mega electron volt electron flux. These are the electrons that surround the Earth in things called the Van Allen belts. We'll show you a diagram of that later in the video. First, the 3-day chart. And we are in normal levels of electron flux here, as you can see by that. Below the warning alert threshold there, no charging hazards expected, and indeed there are no charging hazards for satellites, as high levels of electron flux can charge up satellites and cause them to shut down and do a thing called a CCD bakeout, where the charge couple device turns off to prevent it being damaged. Here's the forecast model for electrons. NOAA forecasting for the same number approximately tomorrow. The green box is the forecast. The yellow diamond is the observation. Here's a diagram of the Van Allen belts along with altitudes of things in miles. Here's a visualization of the electron content forecast. And we see some pretty concentrated regions here. And this visualization will show you the likelihood of GPS errors, as your GPS handset would have to communicate with a satellite tens of thousands of miles away through a large blob of electrons. Here's another diagram of the atmosphere. And I would note the ionosphere. So the next thing we're going to show is the ionosphere, which is this entire region here, all the way to the top of the thermosphere, from the top of the stratosphere to from the top of the mesosphere throughout the entire thermosphere, is a place called the ionosphere. And it's separated into layers called D, E, and F. Those are based on altitude. The lower the letter, the lower the altitude. And we're going to show you about 300 kilometers in vibrational frequency. Here it's the F ionosphere layer. You're looking at vibrational frequency here in megahertz, millions of vibrations per second, as there is a lot of stuff going on where energy from space meets the Earth's atmosphere. It causes all kinds of vibrations to happen. There are all kinds of chemical processes happening up there, particle collisions and so on. And the radiation profile is totally different at the ionosphere than it is here on planet Earth. Ionosphere looking a little anomalous here. We're seeing some charged down zones here in between these high frequency zones. Some odd shapes and rapid charge ups and charge downs actually happening. The nighttime portion looking extremely discharged. As you can see, a large space. Also an F region forming down here in those red blob areas. And at nighttime, the F multiple layer ionosphere shrinks to an F layer where there's only really one layer. Anyway, there's the latest image from 9:30 Universal Time. Next, looking at some meteorology stuff. And welcome back, Twitch, for a meteorology segment. Starting out things with the jet stream. Here are the jet streams on planet Earth, the Western world, and look at the chaotic jet stream flow here. We got areas of the jet stream blowing due north and due south. It's like a textbook definition here of meridional jet stream flow. The jet stream splits into two here just off the east coast of the U.S., blowing cold air down toward the equator, making for a cold day in eastern Cuba, for example. Here are the surface winds of the Western world. Powerful low off the southeastern coast of South America. Here are the surface winds of the eastern world. And here are the jet streams. It's 250 hectopascals. If you're wondering, we are on nullschool.net. I would once again remind you to follow us on Instagram. And I wanted to just take a moment during this meteorology segment to show you a perfect example of a frontal boundary. If you think that's a chemtrail or even a contrail, well, you're an idiot. That is a frontal boundary. As we had a warm front moving into Pennsylvania yesterday, and I got a fantastic view of this. I included some choice photos of the frontal boundary. This is north of the Blue Mountain here. This one here is near... This is on Route I-76, the northeast extension, the Pennsylvania Turnpike. And a great example here of a frontal boundary. You can see a different pressure regime. So what we're talking about here is a different pressure and a different temperature on either side of that cloud, those stratus clouds. Those are probably at an altitude of about 3,000 to 5,000 feet. They're pretty low clouds there. And you can see this clear sky. That is the warm front moving in. Perfect example of a frontal boundary. Not quite what we would call a squall line. And yes, I'm a true weather nerd. Next, looking at lightningmaps.org, and we actually see some significant terrestrial lightning here striking in Texas and Oklahoma. Shout out to our Texas and Oklahoman viewers. If you're in Oklahoma City, go out and look to your southeast. There's quite a light show down there. And you're actually looking at the propagation of thunder. It's lightningmaps.org. It's where I go when I hear thunder. It could save your you-know-what and prevent you from doing something stupid and going right outside to where there's a massive thunderstorm happening. Significant thunderstorms that are happening. So here's the NASA GOES lightning mapper. And I think we're looking at about 6 hours here. From 3:30 to 9:25. So 6 hours of data there. The NASA GOES lightning mapper. And I included the scale down here to show you the scale is indicating number of flashes per 5 minutes. Next, we're looking at pressure on windy.com. They've got a great mobile app, by the way. We're not paid to say that. I just use it. But in any case, there is the GFS forecast for pressure at 12 noon tomorrow. And if you're wondering where we're located, folks, we are located here in eastern Pennsylvania, Lehigh Valley /PA/US. Right about here. Here's a U.S. Doppler radar map, and you can see that long string of storms from central Texas stretching up to the Missouri-Arkansas border. Also some strong storms in Nebraska and over Lake Michigan. Some snow falling in northern Colorado, as well as some snow showers happening in places like New Mexico, Arizona, and Utah, as it's April 28th and the snow continues to fall. Will it be a year without a summer? Leave us a comment. Let us know your theories. Let us know your theories about the way one large volcanic eruption could reduce the population of the planet by massive quantities. Anyway, here's what's going on in the cloud layer. And here's the water vapor map in case that wasn't enough information. And you can see massive pressure gradients being created in here, as dry air, folks, is more massive than moist air. So this air right here, much more massive than this moist air, and those massive pressure gradients have a tendency to produce violent weather. And you can expect these systems to move rather slowly here. As you can see, this dry air is not moving particularly quickly. The jet stream isn't really playing much of a role with this, and that is why these systems are going to stagnate a little bit. And that's today's meteorology segment. We'll have to say goodbye to Twitch once again. Bye, Twitch. Here come bonus features. Bonus features, and thanks patrons, will consist of the latest imagery from El Teide, Spain. Part of the National Sunspot Observatory. And I still see some filaments down here. You can see those dark areas. I still see some filaments up here. So the possibility of additional coronal mass ejections in the Earth-facing vicinity continue. Again, we're expecting a coronal mass ejection to strike today and early in the day on May 1st. Thanks for tuning in, Smash Team. Thanks to the most important members of Smash Team, our patrons. These videos are brought to you in part by our patrons, the main source of funding for the content. If you'd like all kinds of alerts and multimedia that nobody else in the world gets, consider becoming a patron. Our lowest tier is only $3 per month, so open up your cobweb-encrusted wallet and send us $3 a month or more to increase the probability that these videos will continue to exist and remain publicly visible. Here comes some more bonus features in the form of the high-resolution colorized magnetogram. We're going to make sure we have the most updated imagery here. There's your refresh. And here's the intensitygram. We're going to zoom in on this region right here. There's the colorized magnetogram, and you can see these sunspots have all degraded except 2818. 2818 is just an alpha-class sunspot, which is hanging out and staying pretty similar. Looking a little bit like an iron cross there. Please leave a comment if you're afraid of shapes. So again, there's the colorized magnetogram. Here is the intensitygram. Here's a close-up of the most active region on the sun here. Sunspot 2018, 2020, and 2021 in 193 angstroms, which is one of the ionized states of iron and the UV emission spectra thereof. It's some hot gaseous iron, folks. And last but not least, here's 171 angstroms, my personal favorite wavelength. Should show a couple B-class solar flares happening here. In any case, thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics. Welcome to the Neo-Renaissance. Visit our links, support our content, and since it'll never be now again, may that solar wind be at your back.